On the 27th of May 2021, in the high desert west of Delta, Utah, 507 plastic boxes sat in the dark, doing what they had done every night since 2008. Nothing. They are scattered across 700 square kilometers of scrubland, each one about the size of a kitchen table, each one a kilometer and a half from its nearest neighbor. They are not telescopes. They do not look at anything. They simply wait in the driest, darkest air in the continental United States for something to fall on them. That night, about 24 of them registered a signal within microseconds of each other. Nobody saw anything. There was no flash in the sky, no sound, nothing that would have troubled a person standing in that desert. The thing that triggered those detectors had already ceased to exist. It had died about 30 kilometers above their heads, in its first and only collision with our atmosphere. And what arrived at the ground was not the object itself, but its wreckage. A cascade of secondary particles spreading downward and outward in a thin disk, raining across several kilometers of Utah at almost the speed of light. From that wreckage, physicists worked backwards to what had made it. What they found was a single atomic nucleus. Not a rock, not a fragment, not a grain of dust. One nucleus, smaller than an atom, carrying a quantity of energy that has no business being attached to something that small. The University of Utah, trying to make it comprehensible, described it this way: the force of a brick dropped on your foot from waist height. That is the everyday version. Here is the physics version. It carried roughly 40 million times more energy than anything the Large Hadron Collider, a machine 27 kilometers around, buried under 2 countries, the most powerful accelerator humanity has ever built, has ever managed to produce. They named it Amaterasu, after the Japanese sun goddess. Particles like this are almost unimaginably rare. The estimate is roughly 1 per square kilometer per century. That is why the detectors are spread across an area the size of a city. Not to catch many, but to have any chance of catching one. In more than a decade of watching, the telescope array recorded exactly one event at this energy. It was not, however, the first. In October 1991, in the same desert, a different instrument recorded something even more extreme. It was nicknamed the "Oh my God" particle, and it carried around 320 exa-electron volts of energy, the highest ever measured, before or since. It arrived, it was recorded, and then 30 years passed without an explanation. Which brings us to the actual problem. Not the energy, where it comes from. To accelerate a single nucleus to this speed, you need something enormous. Not just a violent event, but a violent event with immense magnetic fields, strong enough to hold the particle in place while it is repeatedly whipped faster and faster. One of the researchers on the 2023 paper put it plainly: the things people instinctively think of as powerful, like exploding stars, are nowhere near sufficient. Supernovae are not in the running. The candidates are the extreme objects of the universe, the shock waves around supermassive black holes, the collapse of massive stars into gamma-ray bursts, the vast radio structures thrown out by active galaxies. There are not many of those. And critically, we know where they are. Now here is the detail that turns this from a curiosity into a genuine problem. Particles at this energy cannot travel far. Space is not empty. It is filled with the faint microwave glow left over from the Big Bang. To you and me, that radiation is harmless and almost undetectable. But to a nucleus moving this fast, each of those cold photons hits like a hammer. The particle loses energy with every collision, steadily, unavoidably. Physicists have known this since the 1960s. It sets a hard limit, a horizon, beyond which nothing this energetic can reach us. which means the energy is a clock, and the clock says recent. It says nearby. The estimate for Amaterasu put its origin within roughly 100 million light-years. In cosmological terms, that is the neighborhood, our own back garden, a region we have mapped in detail, galaxy by galaxy, for decades. And there is a second gift. At these enormous energies, magnetic fields barely bend the path. A low-energy cosmic ray arrives, scrambled, its history erased by every field it has passed through. A particle like this flies almost straight. It should point home. So they took the arrival direction, a precise line on the sky measured to within a degree, and they followed it backwards, out of the atmosphere, out of the solar system, out of the galaxy, into the local universe, looking for the object that made it. The line points at the local void. The local void is a region of space adjacent to our own group of galaxies. It is not empty in the way a room is empty. It is empty in a way that is difficult to hold in the mind. A volume tens of millions of light-years across, in which the density of galaxies is around 1,000 times lower than in our own neighborhood. A few faint dwarf galaxies drift in it. There are no active galactic nuclei. There are no colliding giants. There is nothing capable of doing what was done to this particle. The line points at a place where there is nothing. One of the study's co-authors said something in 2023 that scientists very rarely say out loud in public. Asked what could account for it, he offered defects in the structure of space-time and cosmic strings colliding, and then immediately admitted he was throwing out wild ideas because no conventional explanation was available. That is not a scientist being dramatic. That is a scientist being honest about the size of the gap. And there was one more thing that made it worse. The oh my god particle, 30 years earlier, had come from a completely different part of the sky. So this is not one hidden object we have failed to notice. It is a pattern of arrivals with no pattern. A category of event, occurring repeatedly, with no confirmed origin for any of them. Since 2023, researchers have been working on a way out, and it is worth understanding because it is subtle and it does not resolve the way you might expect. The escape route is mass. Everything so far assumed the particle was light, a proton or something close to it. But if Amaterasu was heavy, an ion nucleus rather than a single proton, then it carried far more electric charge. More charge means magnetic fields grip it harder. A heavier particle bends, and a bent path is a lie. The direction it arrives from is not the direction it came from. Recent work modeling this in detail found that if the particle was iron, and if its true energy sat toward the lower end of the measurement's uncertainty, then the possible origin opens up considerably. Out beyond the local void to real objects, including a galaxy called M82, a furiously star-forming system close enough to be a plausible candidate. That sounds like a resolution. Read it again. The answer depends entirely on what the particle was, and we cannot find out. For a single event at these energies, the composition cannot be pinned down. The nucleus was annihilated in its first contact with the top of our atmosphere. Everything we know about it, its energy, its direction, its existence, was reconstructed from the debris of its own destruction. The one measurement that would tell us where it came from is the one measurement it took with it. It traveled, in all likelihood, for tens of millions of years. It crossed a distance that dwarfs every human timescale. It arrived carrying a single line of information, a direction, and that line either points at an empty region of the universe, or it is a forgery produced by magnetic fields we cannot map. There is currently no way to tell which. Tonight, more of them are arriving. Not many. but the sky has never stopped delivering them. Most fall on ocean, some on ice, on forest, on desert with nobody in it. Some on cities, passing silently through roofs and rooms and the people inside them, unrecorded, unmeasured, unnoticed, because there was no instrument standing underneath. In more than 60 years of looking, we have caught a handful. And every so often, one of them arrives from a direction where our maps show nothing at all, carrying a message we can read from a return address that does not exist.